For this example, we're going to imagine a ball placed again here at the top of the ramp, held steady for a moment. It's going to be released. It's going to roll down the ramp. It's going to get to this little bend in the ramp, and the dots are for, I'll show you a reason in a second. It's going to then roll across this flat section of the ramp and continue on. I don't know where it's going to go after that, but let's imagine that it's going to continue on and continue doing what it's doing. The bend in the ramp breaks the motion into two distinct sections. We have the first section and the second section. And so as the ball rolls down the ramp, the acceleration on this side is going to be to the right. I'm going to label right as positive. However, once it crosses past this bend, it stops speeding up or slowing down. It just continues to roll at a steady speed, or correct at a steady speed, and so the acceleration becomes zero. It's not changing anymore. It's just continuing what it was doing. That's kind of an important thing to understand. And so I'm going to draw an acceleration graph. I can see from here that my acceleration has to be positive for a time, and then it has to become zero. The transition, as far as acceleration is concerned, the transition is pretty sudden. And so we'll represent the transition point with the dotted line, representing the same moment in time as the ball reaches here. And in the first part of the motion, the acceleration is positive, so I'm going to draw a positive line. And then the acceleration becomes zero, and so I'm going to draw a flat horizontal line right on zero, right at the axis. For the velocity graph, I have the same transition moment in this graph. What we notice is that as the ball rolls down the ramp, the velocity starts at zero and then is moving to the right thereafter. Okay? At this moment in time, the velocity changes from acceleration to just staying, okay, constant velocity. So the velocity starts at zero. It tells me initial velocity is zero. That's a dot right here on the graph. It increases in the positive direction, so that would have to be up here. And then it stays on this flat section of the ramp. The velocity stays constant, so that would have to be out there. So my velocity graph would be like that. Diagonal section where the speed is increasing in the positive direction, and then constant positive speed thereafter. The position graph, again, I'm staying between 0 and 50. So I'm going to label 50 up here, 0 down here. I have, again, the transition. All right. The ball has to get from 0 to 50. So, again, 0 here and 50 there. And I have to get between these two sections, but I have to do it with a combination of a top opening parabola, because positive acceleration is a top opening parabola, and a straight diagonal line, because zero acceleration would mean constant motion, which means that x is a diagonal line. So I need a top opening parabola and a straight line. That would have to be this, and then it should be a nice smooth transition into a straight line. Sometimes when drawing these, it's a little tough to do that, and they come out looking, kind of like that. Not the worst thing in the world, since we're just going for the concept of what's happening, but in reality, we'd get a fairly nice, smooth line in the transition between those 2 points.